In this video, we set out to estimate the Taylor rule over varying time periods. After downloading data for selected time periods, we calculated the growth gap, also known as the output gap, by calculating the actual growth rate minus the trend rate, which we use to calculate the Taylor rule. The Taylor rule calculates what the federal funds rate should be as a function of the output gap and current inflation, as you can see by the basic formula here. We ran a regression using the Fed funds rate from the last quarter of 1987, when Alan Greenspan was in charge, to the last two periods of 2006, and we used independent variables of inflation and growth gap. This is an array output, as we can see, and it shows us that the coefficients are reversed from what the order was here. As we see, it's 0.36, 1.5, 0.46. Here's the coefficients, the standard error, and the t-stats. If the t-stats are over 2, we say that they are statistically significant. In order to calculate the Greenspan fit, we use the basic formula and input the coefficients here into the formula. So we use the A plus B1 multiplied by inflation plus B2 multiplied by the growth gap. And this gives us the Greenspan fit for the selected time period. In order to calculate the Taylor rule, we change the coefficients as set here as 1, 1.5 and 0.5. In this case, the values here of what the federal funds rate should have been if it had been following the Taylor rule. And using the graph below, we can shows what the relationship was between the actual Fed funds rate, the Greenspan fit, and the Taylor rule. As you can see, the graph reflects that the Taylor rule suggests policy would have been more accommodative in the way interest rates were set. The high Fed funds rate towards the latter stages of the 1980s reflects the period of aggressive inflation. After 2001, the Fed funds rate was kept artificially low and shows that it was more accommodative in comparison to the Greenspan fit and Taylor rule. The low level set by the FOMC reflects increase in asset prices on the lead up to the financial crisis. In this part, we show the relationship between Taylor rule and quantitative easing. Using the same data in Greenspan fit and Taylor rule, we show that the relationship between the Fed funds rate and the Taylor rule. As you can see, the negative Taylor rule coincided with the initiation of quantitative easing after the financial crisis. The Fed funds rate has remained low since the financial crisis, and as interest rates cannot be negative, as we can see here, it shows that the period over 2001, the period has been significantly low, only a marginal increase in early 2016. The Taylor rule offers us a rationale for why quantitative easing was introduced. It offers a policy tool that can be used when the output gap is negative. And using the results from RStudio, we back up our data to make sure that the results are correct. We see that results are quite similar. After changing the data by increasing the decimal places, we see a similar levels from what our levels given as Excel to RStudio. As you can see, coefficient 0.3632 is similar to this, a coefficient of A, and likewise.